Heat and temperature. Heat is a form of energy. If heat is given off through a chemical or physical process, the process is referred to as exothermic. An example would be combustion, or burning of a substance. If heat is put into a process, the process is endothermic. When boiling a liquid, you need to put in heat to bring the substance from the liquid to the gas phase. Heat and temperature are related but are not the same thing. There are three temperature scales in common use. In the United States, we still use the Fahrenheit system, where water freezes at 32 degrees and boils at 212. In other parts of the world and in the lab, we generally use the Celsius scale, where water freezes at 0 degrees and boils at 100. The Kelvin scale starts at absolute zero, the lower bound of temperature that can be approached but not quite reached. The size of a Kelvin is the same as a degree Celsius. To convert from the Celsius to the Kelvin scale, just add 273.15. This slide also summarizes the material of the last slide. We can use formulas to go back and forth from the Fahrenheit to the Celsius scales. My advice would be to choose just one formula, memorize it, and use it for all the conversions. Again, temperature and heat are related, but definitely not the same thing. Heat is the transfer of thermal energy between two objects that have different temperatures. Temperature is a measure of the average kinetic energy of a substance. Heat is measured in joules or calories. Temperature is measured in degrees. The temperature doesn't depend on the amount of substance present, but heat does. The idea of heat capacity helps us to relate the amount of heat with a temperature change. With heat capacity, we must remain in the same phase. The specific heat capacity of a substance is the amount of heat required to raise the temperature of 1 gram of the substance 1 degree Celsius, or 1 Kelvin. Remember that the size of 1 Kelvin is the same as the size of 1 degree Celsius. The two scales are just offset by 273.15 degrees. The amount of energy that is transferred as heat is dependent on the mass of the material, the specific heat of the substance, and the change in temperature of that substance. The units of specific heat are joules per gram degrees Celsius. However, as long as one has energy divided by mass times temperature change, the values are valid. You might see specific heat labeled as calories per gram Kelvin. Specific heat is a physical property. It is dependent on what substance you have. Water has a very high specific heat. Metals have much lower values. For this sample problem, we have to rearrange the equation to get specific heat isolated. The equation will have energy divided by mass divided by temperature change. We have 174 joules of energy, the mass is 14.3 grams, and the temperature change is 27.0 degrees. You should get 0.451 joules per gram degree Celsius. This is definitely not the specific heat of gold. We often use metal sheets or plates to transfer heat away from where too much can do damage, such as in electronic circuits. Also, it is the high heat capacity of water which allows us to remove a lot of excess heat from our body by evaporating sweat.